Assalamualaikum. Myself Ahmedullah Khan, roll number 21T76, and I am here to perform the lab number 4 of digital signal processing. So we will move to its first task, in which we have to differentiate between signal and system by providing its key characteristic and examples. So signal is representation of physical quantity that varies with time, space, and any other independent variable. Its key characteristic is that signal can be analog, digital, continuous, or discrete, or can be one-dimensional or multidimensional. An example is an audio waveform captured by microphone is a signal. It represents a variation of air pressure over time, which carries sound information. Now we will move to the system. A system is integrated process input signal to produce output signal. It can be physical, such as electrical circuit, or mechanical device, or abstract. Its key characteristic is that system can be linear or non-linear, time invariant or time varying, causal, non-causal. That can be represented by mathematical models such as differential equations, transfer function. And this example is an audio equalizer in music player is a system. It produces the audio input output audio signal by adjusting the level of different frequency bands to produce the discrete output. Now we will move to task 2, in which we have to test the role of linear time invariant systems in digital signal processing. So by using its mathematical simplicity, adherence to superposition principle, and efficiency in frequency response analysis. With mathematical simplicity is that LTS systems are characterized as linear operations and time invariants, which make them mathematically tractable. That can be represented by linear constant coefficient difference or difference equations. Is adhere to superposition principle that LTI system adhere to the superposition principle, which states that the response of a system to sum of multiple inputs is equal to the sum of response of each individual input. And its efficiency and frequency response analysis is LTI systems have a well-defined frequency response that characterize their behavior in frequency domain. This frequency response can be efficiently analyzed using using techniques such as Fourier transform. So, in short, a frequency response of LTI system facilitates the analysis of stability, distortion, and other performance metrics, allowing for optimization and improvement of DSP algorithms and systems. Now we will move to a task 3, in which we have to tell the common methods of signal decomposition, especially focusing on technique like impulse decomposition, step function analysis, even or decomposition for analysis, and discuss about their methods. So first of all, impulse decomposition is involved the decomposing a signal into some of weighted impulse signal, and its application is useful in analyzing signal with abrupt changes or transient events such as in fault detection. Now the step function analysis. Step function decomposes the signal into a sum of step functions. So its application is used in control systems and feedback system. Even or decomposition separate a signal into even and odd components based on symmetric properties. And this application is that even of decomposition implies in various signal processing labs such as noise removal, feature extraction, etc. And now we will move to is Fourier analysis. Fourier analysis decomposes signal into sum of sinusoidal components using Fourier transform. Fourier analysis application is that it is used in fundamental in signal processing for taking tasks such as filtering, modulation, compression, and spectral analysis. It allows engineers to analyze and manipulate the signals based on their frequency. And now we will move to now task number 4, in which we have to discuss about convolution and its role in DSP systems. And then we will discuss a fundamental concept of convolution and elaborate on its importance in various DSP applications such as filtering, signal processing. So convolution is a fundamental mathematical operation in serial signal processing. They describe the combination of two signals to produce a third signal. It denoted by the multiplication sign, and it can be defined as the integral of the product of two functions, which one of the function reversed and shifted in discrete time. Convolution represents a sum of product of corresponding samples of two sequences. As you can see, it is in mathematical form. And now we will discuss about its role in filtering. And filtering convolution is extensively used for implementing linear time invariant filters, which are fundamental signal processing for tasks such as noise reduction, signal enhancement, and frequency shaping. Now, in system analysis, convolution is crucial for analyzing the behavior of linear time invariant system by convolving the input signal with system's impulse response. The output signal can be determined. Now, the signal processing convolution is employed in various signal processing tasks such as deconvolution, inverse operation of convolution, cross correlation, a measure of similarity between two signals, and convolutional neural network deep learning model used for tasks like image recognition and natural language processing. Now the last task about which is last task in the sense of theory, that we have to correlate two signals and what are key applications of scenarios where application signal correlation is crucial in various fields such as communication system, radar, and sonar. So in communication system, it is used for signalization and channel estimation. In radar and sonar, it is used for target detection and tracking. Doppler shift estimation in image processing. It is used for template matching and motion estimation. And in biomedical signal processing, it is used for electrocardiogram analysis, brain signal analysis, and last one control system. It is used in not the last one, but second last one. It is used for system identification and feedback control. While in wireless communication, it is used for channel estimation and beamforming. And last one, now the last one, is seismic signal processing. Seismic signal processing. It is used for earthquake detection. And at this point, our theory tasks ended. Now we what's our MATLAB task. In first task, we have to make a function of convolution demo in which we have to input two signals and then convolve them and then plot them. I will plot them in discrete signals. So here I use stems function. So when I will run it, so where you can see that it asks for one signal. So I give first signal is equal to that, and then the second signal is and when you convert it, here it shows the graph. So I show the graph. It's been late, but it shows that first signal we give is 1 to 1, and second signal we give is 3 to 1. And when we'll convert them, we will get at 0. We will get 1, and in 2 we will get like something a middle point. And as you can see that we will get the convolution results right here. So the second is also that in which we have to show step-by-step convolution. So like that, as per the previous one, we also give two input signal and then we convolve them and then we plot them by using a discrete signal command stamp. And when we run them, I will give the same signal as I given to the previous one. So and I run it. As you can see that I will get the same graph as I get from the other one because I given the same signal. So at the end, yes, you can see that there is a convolve result of the given two signals. Now we will move towards a third task in which we have to make a function in which we get the system response. So I make the function of system response to display commands. I use display commands and then calculate its length zeros, and then I use for loop for function, and to make it runnable I make the function to call it, and then and we move towards the command. So you can see that the input signal is that its impulse response is that, and when we combine both of them the output signal is like that. Now moving towards our last task, in which we have to give the impulse signal and original signal and then convert them and display them, and then we will add the shifted signal in them, and then we are convert them and then display the shifted signal. So when I run it, first of all I clear the output window so that you can clearly see the result, and then when I run it you can easily see that first the output signal when we add one impulse signal in it with that, and after adding the shifting signal it is like that. So at that point our whole lab is finished. Okay, Allah Hafiz.